Today we're going to look at a couple more fractals. The first one we're going to look at is called the Sierpinski triangle. And for this one, our initiator, and remember initiator means what we start with, initiate like beginning. So what we start with here is going to be a triangle, and then our generator, and remember generator is like our rule that we follow. Our generator is going to be to connect the midpoint of each side and then shade in the triangle that will make. And then as we continue on, we're only going to divide up the triangles that are not shaded in. It says, for our example, we're going to begin with a generator of size 12 for each side of the triangle, and then we're going to do 3 iterations. Remember, an iteration is kind of how many repeats of that rule that we're going to do. So we're going to start by making a triangle that has sides of length 12. Oops. So it's our initiator, has sides of length 12, and then for our generator, we are going to find the midpoints of each. So if each side has a length of 12, that would be 6 units in, would give us our middles. And we're going to connect those and make a triangle out of them. And then we're going to shade in that resulting triangle. So that's our first iteration. Then it says to do 3 iterations, and on each subsequent iteration, we are only going to divide up the ones that haven't been shaded in, because that's shaded in so much so that I can't actually see if I would try to draw on it anymore. So we're just going to divide up the 3 remaining white triangles, connecting their midpoints and making new triangles in there. And then shading in those resulting triangles in the middle. So this is what it would look like after 2 iterations. And our directions tell us to take it to a 3rd iteration. When we take it to that 3rd iteration, when we find our midpoints, they're actually not going to be along the lines on the paper. It's going to be right in the middles there. Since our triangles at this point have side length 3, we need to cut them up at the 1.5 point. And so this is what it would look like after 3 iterations. Now remember, a fractal is something that really in reality is completed to infinitely many iterations, or that it's really never completed. Keep on dividing up the white spaces into smaller and smaller and smaller and smaller, and keep on shading in those middle pieces. So that we said that a fractal is self-similar, so that if we would keep on zooming in and zooming in and zooming in, we would keep on seeing the same exact thing. Okay? Or that if I cut out just one portion of this and blow it up, it would look just like the original. All right. Questions on the Sierpinski triangle? So we're going to look at is called the Sierpinski carpet. Same name, so it's going to be kind of a similar idea here. But what we're going to do is use square paper, and we're going to start with a square will be our initiator, and then our generator is going to be that we're going to divide that one square into 9 squares. So we're going to cut each side into thirds, which will give us 9 squares inside of the original, and that we're going to shade in everything except the center. Then on subsequent steps, we're going to divide up the ones that are shaded into squares and shade in everything except their center. A pencil should be used on this because we're going to end up needing to erase portions since we're going to be cutting up ones that we've already shaded. We'll need to then erase out portions of that. So a pencil would be really helpful for this one. For example, it says that we're going to be using a generator of side length 27, which is exactly how much I gave you. So you don't need to worry about counting to 27 to make our original square. Then we're going to draw 3 iterations. And again, the warning that we're going to need pencil because we're going to need to erase shading here. So the whole square is our initiator, the whole grid. And what we're going to do for our generator is divide it up into 9 squares. So if the side is length 27, we're going to want to cut that into a third, so we need to count over 9 squares to make our division. Okay, so counting out 9 units along each side and cutting up those squares, I turn the one square into 9 equal squares. Like a tic-tac-toe. Or a bunch, if any of you have ever seen that way before your time. Then our generator says that we're going to divide it up into those 9 squares and we're going to shade in everything except for the center. Really lightly, I'm just going to scribble a little bit throughout everything except for the center, but we're going to end up needing to erase it, so I don't want to do like really thorough shading here at this point. But everything except for that center one, we want to shade in. No, just do it like this for now. Just do some light shading because we're going to end up having to do some erasing, so we don't want to make it like really heavy shading at this point. That just makes it harder to erase. So then for our next iteration, we want to cut each of the squares into 9 squares. So they're of length 9 now, so we'd want to cut them into length 3. So I'm going to cut up by 3s this time, cutting up everything except for that center one that is not shaded. That one I don't want to touch, but everything else. So once I have all my grid lines in there so that everything is now cut into squares of 3 by 3, except for that big blank middle. That's still just going to stay 9 by 9 forever. But all the other ones break up into now 3 by 3 squares. And then what I want to do is erase out the center part of each of those. So any of the shading that ended up in the center of those, I want to erase out. So the center 3 by 3 square, and each of them should be erased out. So along the top, you'll have 3 center 3 by 3 squares, And then in that middle one, you'll have 2 center 3 by 3 squares, and on the bottom, you'll have 3 center 3 by 3 squares. It gets kind of tricky to look at so many squares at the same size. Our directions told us to go to 3 iterations. I'm not going to do the entire grid to 3 iterations, and I'm not going to ask you to do the entire thing to 3 iterations either. But I'm at least going to start at the upper left and start dividing up. So if I go another iteration now, cutting each of these squares into 9 squares, that means each square is just going to be 1 by 1. So now every line here is going to be its own division. And in all of those little 1 by 1s, I would want the middles to be blank. So that's what that top one would look like after a 3rd iteration if I really shade it in. And then if I would go to a 4th iteration, I would cut each of those individual squares into 9 squares and continue this process infinitely. This process could continue, but we're definitely not going to take it any more than here, and you don't even need to complete this whole 3rd iteration. But if I would go over to the next one, so that's what that next little square across the top would look like, and each of the squares around the outside would all look that same way as we completed it. So some definite similarities between the Sierpinski carpet and the Sierpinski triangle, more than just their name, that it's the same guy that thought about these 2 different things, but the idea of dividing up and doing a shading in a fractal instead of just a cutting or a drawing like we did in the previous lesson. Questions? Our final fractal that we're going to look at today is called a fractal tree, and you'll be able to see once we start drawing this out why it's called a fractal tree, because it's going to kind of look like a tree. Our initiator is going to be a line segment, and our generator is going to be an angle at which we are going to divide that line segment. We're going to begin with an initiator of a line segment of length 4, or kind of the tree trunk will be that line segment of length 4. And then the angle we're going to use is 60 degrees because that's the angle in this triangular graph paper, so that will make it easiest for us if we do that 60 degree. We're going to kind of make a little bit of a false measurement just to kind of simplify things. We're going to say that when I draw a height of 4 across the middle of the triangles, it's still going to count as 4. And the sides are going to count as 4, which is not really true. Those heights are taller than the sides of the triangles, but to avoid having to multiply by square roots of 3s and get out rulers and all that, we're just going to say 4 is 4, whether it's along the side of a triangle or in a triangle. So that's our initiator. Then what we're going to do is break it up, and at each division, the branches are going to become half as long as the previous. So this one has a branch of 4. So as we separate out at a 60 degree angle, it's going to create 2 branches that have length 2. Then, at our next iteration, we're going to separate each of those out at 60 degrees, and they will just have length 1. And that's going to go in the triangles instead of along the triangles this time. So it'll go every other, kind of in the triangles, along them, in them, along them, as we move through the graph paper. Then we're going to take each of those and break them up. And then those are going to have length of 1/2. And then we could do it again, breaking each of those up, and they would just have length 1/4. And we could continue this process infinitely, because that's truly what a fractal does, but our pencils are probably getting about to their limit of being able to draw. The next one would just have a length of 1/8, so it'd be really tiny to draw those next ones. Okay. But we can see that it's kind of starting to look like a tree branching out. Question?